Hello, my name is Patrick Payne. I'm the Chief Technology Evangelist here at Zumasys, and today I want to show you jBASE and a HA failover process. Up front here, we have a diagram. The way this is going to work is we have three database servers, primary, secondary, and a third one, and we're using JLog dupe to transaction journal updates from DB1 to DB2 and DB3. And DB2 already has jlog dupe up and ready in case it takes over to TJ over to DB3. In this situation, we are running two jBASE application servers. We're calling them Web 1 and Web 2. They connect to the database over jRFS, and locking is done on DB1 and DB2. This is what's called distributed locking. We then have two HA proxy machines that will proxy web traffic to each web server on a round robin, a telnet proxy that will bring in telnet traffic. And then we also have an Nginx management console that allows us to talk to each one of the jBASE boxes and get a status. The failover is where we take DB1 and we will actually just kill it. We will then tell the app server to start talking to the second jRFS server through a DNS update, and activity will take off. So when the failover is done, the cluster will look like this. To do this testing, we are using Docker and Docker Compose. It's an excellent tool for mimicking a large network configuration such as this. So over here, I have a Docker Compose file where it builds each one of our database servers, our application servers, and we took two app servers, base them on the same image. We then have our web proxy, our telnet proxy, and our Nginx box. And with typical Dockers, each one of these images are within a directory with a classic Docker file. So here is a jBASE box. We copy in the items we want, fire up the machine, run an entry point script. And with jBASE, because we're native to the OS, this standard Linux script will then build the entire machine out. So this is starting with a jBASE install, but it actually brings in accounts, configures the entire machine, brings up and configures transaction journaling, brings up our jDLS server and our jRFS server, creates our demo files, brings in our cluster manager account, and then starts our TJ. So each one of the scripts are very similar, except for the TJ setup will be different from machine to machine. And if you're interested, bringing up the proxy servers is as simple as bringing in, for example, web proxy. We look here, it's a standard Docker file bringing in, well, this is the app server, but if we look at web proxy, just bring in HA proxy and copy in our configuration files. And over here, we just have standard configuration files to then set up Web 1 and Web 2. We then go off and run a Docker Compose, which will bring up the environment. I've already done that. It takes about a minute for it to start the environment. And then we bring up our whole cluster. So here you can see the whole cluster running. DB1, DB2, DB3, our Nginx server, our two app servers, and our telnet and web proxy machines. So now we have our cluster up and running. I am going to minimize these windows and show you the machine. So here we can see if we touch my internal web server, we are actually rotating between the two web servers. We go over here through our management interface, we can see DB1 situation. And here you can see it has two TJs running, and it's sending out information. And here's the locking tables. Here's DB2. It has one reading and one sending, because remember it's replicating to DB3 and its logs, locking table. Here's DB3. It has two receivers for TJ. And then here we can even see our application server. So what we're going to do here to demonstrate a failover is we're going to do a very simple select our orders file. Actually, let's first list it. So remember, this file is on this machine, and this is set up with a Q pointer. And in our system file, we have a DB server R pointer that points to DB primary. And if we go over here, we have a DNS entry set up on the machine that's pointed at the primary server, which is 5, and DB2 is 4. So now what we're going to do is select the orders file, ed the orders file, and we should have taken a lock. So if we go over here and look at DB1, we will now see that a lock has been taken for item 393, which is the record we edited. And you'll see that a lock is taken both by the excuse me, by the app server and actually the database server. And if we go to the second server, we'll see that a lock is taken by the app server. And this is what's called distributed locking. So both the app server is connected to both of those jDLS servers and requesting locks. So if we lose one of the servers, the primary server, our locks are still held. And to demonstrate this, if I go over to the second session here and ed orders 393, we'll see that the record is locked. Now what we're going to do is we are just going to kill the database server. So go to DB1 and we are going to kill it. I'll take a second here. But this is demonstrating worst case scenario that the machine completely died. So now we're going to go up here and we are going to actually make a change to this record and we're going to try to save it. And we'll see that it's going to sit there paused. The jDLS locking daemon will actually switch over and connect to the second box. If we look at our locking table, the second box, we will still see that our record is locked. And once we go over here and update and point to the machine, but you'll see as soon as I write this line here, and I think it's on about a 5-second retry, we'll reconnect and write out its record. So now if I go over here, and we try to edit record 00393, and what you're seeing is this pause is actually, because we're at a J shell, that the jDLS locking daemon is timing out. So we'll see here, see that my change is there. If I do a ed of orders, it's locked. So we've just now issued a failover. And if we go now to our DB3 box, we will see that our record is updated on this machine. So at this point, we are in a failover situation. We are now running on the DB2. We could actually issue another failover and switch to DB3 by updating this entry. And full recovery of bringing a second and third nodes back in line is just a process of updating our config records to a point at which servers we are now viewing as primary and secondary, and those servers will start maintaining locks on the second and third servers. So thank you so much for watching this quick demo. If you have any questions, please contact us, and we will be happy to walk you through a more in-depth demo. Thank you very much.